So in the university question paper, you can see that always the 9th question is an FFT problem. So it is a 100% sure question of 10 marks. So in this case, x of n is given, then you have to determine the DIT FFT algorithm. The scheme is given: signal flow graph of DIT FFT 3 marks, then intermediate calculations 3 marks, then final answer 4 marks. So the final answer is also given here. Let us try to solve this problem. Given x of n equal to the data, and we know the trivial factors. So as a first step, the trivial factors W80 equal to 1, W81 equal to 0.707 minus J 0.707, then W8 raised to 2 equal to minus J, and W8 raised to 3 equal to minus J, minus 0.707 minus J 0.707. So next step, it is better to write x of 0 equal to 1, x of 1 equal to, so we can write x of 0, x of 1, x of 2, x of 3, like that. So this will help you to obtain the bitwise order easily. The next stage, you draw a straight line, the sufficient space in both sides not to give the input and output data. Then location for first stage of the butterflies, which is a 1 by 1 butterfly. Then again give the struct space for the second stage butterfly, it is a 2 by 2. Then again some space and give sufficient space for the 4 by 4 third stage butterfly. Then you can draw the next 7 parallel lines. So overall we have the 8 parallel lines. Then simply give the markings. This can be done using a scale. So here marked. Next we can draw the butterflies. Stage 1 butterflies. So this is the stage 1 butterfly. Now we can go for the stage 2 butterfly. So this part to this one. Next we go for the stage 3 butterfly. Now the signal flow graph is over. Now you have to give the data. So the input of the last stage, trivial factors at the input side of the last stage, that is W8 to 0, W8 raised to 1, W8 raised to 2, W8 raised to 3. Then the corresponding to till factor we can give -1, -1. Then at the second stage we have the till factors here, W8 to 0 and W8 raised to 2. Here we have W8 raised to 0, it is W8 raised to 2. And here we can give the negative signs. Next, the stage 1 till factor, which is all 0, W8 raised to 0. Here again, the till point we can give the arrow mark with the -1. Next, you can give the sufficient number of arrow marks. So next stage we have to give the bit reversed order input as the data. So we have the decimation in time FFT algorithm. So the input should be in the bit reversed order. So the bit reversed order, you must memorize it. So memorize that the bit reversed order, the first value is x of 0 itself, which is given as 1. Then the second one is x of 4, which is equal to x of 4 equal to 4. So the bit reversed. The next one is x of 2, which is equal to x of 2. Here we have equal to 3. Next is x of 6, which is equal to h of 6 equal to 2. The next one is x of 1. X of 1 equal to 2. The next one is x of 5. X of 5 equal to 3. Then x of 3. X of 3 equal to 4. The next one is x of 7 equal to x of 7 itself, that is equal to 1. So this is the input data in the bit reversed. So after giving the input data in the bit reversed order, we can have the stage 1 computation that we can very easily done. First one is 1 plus 4, the sum of the two, that is 5. Then the second data subtracted from the first one, that is 1 minus 4, which is equal to -3. Here it is 3 plus 2, 5. Then 3 minus 2, it is 1. Then 2 plus 3, it is 5. Then 2 minus 3, it is -1. Then 4 plus 1, it is 5. Then 4 minus 1, it is 3. So the stage 1 computation over. Next, the stage 2 computation. Here the input data we can see it is 5, and here it is 5 into W8 to 0 is 1. So this is equal to 5 into W8 to 0 is 5 itself. So 5 plus 5, it will be 10. Then at this stage we can see it is -3 and W8 raised to 2. W8 raised to 2 is minus j. So this will be -3 minus j. Then here we can see the input data is 5, is -1. So 5 minus 5 into W8 to 0. That is 5 minus 5, which will be 0. Now for this stage it is -3 minus W8 to, that is -3 minus j. So it will be -3 plus j. Similarly here 5 plus 5 equal to 10. Here we have -1 to 3. 3 into this. It will be -1 minus j 3. And at this stage we will be having 5 minus 5 into W8, so that is 5 minus 5. So it will also be 0. At this stage we can see it is minus 1 into minus 3j. So it will be minus or minus, it will become plus. So it will be minus 1 plus j3. So here we can see this is the, with respect to the 0, it is in the complex conjugate. Here also with respect to 0, it is the complex conjugate form. So the second stage computation is over. Now the last stage of the computation, here the value is 10 plus 10. So it will be 20. Now coming to this point, the input here is minus 3 minus j, and here it is minus 1 minus j3 into w8 raised to 1. w8 raised to 1, we know that it is 0.707 minus j 0.707. So first you multiply minus 1 minus j3 into, these two are complex numbers, minus into j 0.707 minus j 0.707. So using a calculator you can easily compute this one. Now that data, that is this minus 3 minus j plus the multiple data, you have to summing up. Then these two are summing, you will be getting the value as minus 5.828 minus j 2.414. In a similar manner, you can get the output of, here it is 0 and here again 0. So the output will be 0. Now this value means minus 3j, minus 3 plus j plus the minus 1 plus j3 into w8 raised to 3. w8 raised to 3, as you know, it is minus 0.707 minus j 0.707. So multiply these two and add with this number, so that you will get 0.172 minus j 0.414. Here the input is 10 minus 10. 10 into w8 0 means 1. So 10 minus 10, this value will be 0. Next you compute this point. This point means is minus 3 minus j minus the complex multiplication of these two values. So we know that it will be the complex conjugate of this one. So compute and ensure that it is a complex conjugate for, similarly this point will also a complex conjugate. Here you can see these inputs are 0 plus 0, it will be 0. Then the last value will be the complex conjugate of this one, minus 5.828 j 2.414. So while computing, you must independently compute. Then you can ensure that whether it is complex conjugate. And if it is complex conjugate, if you get it by calculation, then you can almost ensure that your result is correct. So this is the DFT of the input data sequence. Therefore, x of k equal to 20 minus 0.588 minus j 2.414, then 0, then you have 0.172 minus j 0.414, then 0, then the complex conjugate of this one. Here it is plus j 2.414. So this is our final answer. So we will get 10 marks by solving this problem. Thank you.